Exponents. This is something that we just get tripped on all the time. So let's talk about what an exponent is. Okay, if we have an exponent, we're talking about that little number at the top of a number. Very specific, right? So if I had 2 with a little 4 here, this right here is your exponent. Okay, the 2 is your base, okay? And what this little 4 means is, hey, I'm multiplying 2 times 2 4 times. So that means I have 2 that I'm multiplying 4 times. Okay, so that is equal to 2 times 2 times 2 times 2. That is not 2 times 4. 2 times 4 would be 2 plus 2 plus 2 plus 2. That is not what the exponent is. Okay? This means I'm multiplying 2 times itself 4 times. Okay? So 2 times 2 is 4. And then I would just keep going. 4 times 2 is 8. 8 times 2 is 16. So what that means is 2 to the 4th power is equal to 16. 2 to the 4th power, huh? Okay, when we're talking about exponents, we can say powers. Okay, so if I said 5 and I had an exponent of 7, I would say 5 to the 7th power. Okay, I can do this for any of them. Except, you know, there's always got to be exceptions, right? Okay, we have our little special powers names, okay? And I don't mean like they're special. I just mean they're special ones that we have. Instead of saying to the something power, we have special names for them. So if I have, like, here's just my base number, whatever number that is. If my exponent is 2, I'm going to call that squared. And then if I have my exponent is 3, I'm going to call that cubed. And then all the other ones is just to the power. Okay, to the power of 4 or to the 4th power. Now, you're still like, I really don't understand what you're talking about. So let's talk some more about this. 3 with a little 3 thingy, right? No, that is 3 cubed. Okay, I would say this is 3 cubed. Okay, and I know you're like, oh, that's 9, I know that. That's what we want to say a lot of times, but it's not 3 times 3. It's saying I'm doing 3 times itself, 3 times. So I'm saying 3 times 3 times 3. Okay, not 3 plus 3 plus 3. Okay, so when I'm saying 3 times 3 times 3, 3 times 3 is 9, and 9 times 3 is 27. So 3 cubed is equal to 27. Oh, that's easy. That's equal to 8, right? Nope. First of all, how do I say that? I would read that as 4 squared. Okay? And remember, that doesn't mean 4 plus 4. It means I'm multiplying 4 twice. So it doesn't mean 4 plus 4. It means 4 times 4. So I'm multiplying 4 twice. 4 times 4 is 16. So 4 squared is equal to 16. Now this one just has the exponent of 4, so I don't have a special name for that exponent. I'm just going to say 2 to the 4th power, or I could say 2 to the power of 4. Either one would work, okay? And no, that is not 2 times 4 is 8. That is equal to 2, I'm multiplying 2 4 times, okay? Not adding 2 4 times, but multiplying 2 4 times, okay? So 2 times 2 is 4 times 2, okay, is 8, and 8 times 2 is 16. So 2 to the 4th power is equal to 16. Okay, let's do another one. What do you think this is? I'm hoping you're not saying, oh, that's 6. Well, first of all, how do I read it? Well, it's got that exponent of 2, and remember, if the exponent's 2, we're going to call it squared. So I would say this is 3 squared. And remember, this doesn't mean 3 plus 3. It means I'm not adding 3 twice. I'm multiplying 3 twice. So that really means 3 times 3. And 3 times 3 is equal to 9. So 3 squared is equal to 9. So now we're going to talk about prime factorization. What prime factorization means is I'm going to factor out a number until I get to all of its prime factors. Okay, so what I mean? Well, let's do one. Let's say that I've got the number 36. I want to factor that out so that I only have prime numbers to be able to multiply to get to that number. So what I'm going to do is I'm going to find 2 numbers that I can multiply besides 1 to get to 36. Now there's several ways I could do this. So what's one way? Maybe 3 times 12. Okay, so I'm going to say 3 times 12. So I've got a little branch, and here's 3, but 3 is prime. There's nothing I can multiply to get to 3 besides 1 times 3. But what about 12? No, I could get something out of 12. What's one way I could get to 12? Well, there's plenty of different ways. Maybe you're saying 2 times 6. Okay, so what about 2? Is there any way I can get to 2? Nope, that is prime, so I'm done with that branch. 6? Yes, I can. How can I get to 6? 2 times 3. Very good. Well, what can go into 2? Nothing, that's prime, and 3 is prime. So that means my prime factorization, okay, is I would put that together, and I would say, I like to put it in order from least to greatest, and I'm just looking at the circled things, the ends of the branches, 2 times 2 times 3 times 3. And you're like, why is this video with the exponents? Well, that's because I'm going to use what I know about exponents to condense this. I don't want to have to say, well, 36 is equal to 2 times 2 times 3 times 3. I'm going to kind of condense that. I am multiplying 2 how many times? I've got 2 twice, right, that I'm multiplying. Not 2 plus 2, but I'm multiplying 2 twice. So I could say 2 squared, right? And then times, wait a minute, I see 3 more than once. I'm multiplying 3 twice, right? So I could say 3 squared, okay? So that means I could say that 36 is equal to 2 squared times 3 squared. So that just equals what? What is 2 squared times 3 squared? 36. That's what that means, okay? Because 2 times 2 is 4, and then 3 times 3 is 9, and 4 times 9 is 36. Okay, let's do another one. Let's say that I start with a number like 48. Well, what can I multiply to get to 48? There's a lot of different things, and we could do it lots of different ways. Let's say that I do 4 times 12. What could go into 4? What about 2 times 2? Okay, those are prime, so I'm done with those 2's. What about 12? 2 times 6, okay, there's a 2. That's prime. And then 6, nope, not done with that. So I can do 2 times 3. Yep, that's prime and that's prime. So there's no more branches that are still going. They've all been circled, so they're capped off, so we're done. So that's 2 times 2 times 2 times 2 times 3. Wow, I don't want to have to write all that. Could I condense that with exponents? I sure could. I could say 2 to the 4th power, because that means I'm multiplying 2 4 times 3. And now you're like, but wait a minute, that's not how I was going to do that. Well, that's not the only way to do it. Let's just look at it if maybe if you would have started differently. Maybe you were in the background going, wait a minute, you could do 6 times 8. Okay, let's do that. 6 times 8. What can go into 6? 2 times 3. Okay, 2 times 3. Those are both prime, so I'm done with that branch. 8. What can go into 8? 2 times 4. Okay, 2 times 4. 2 is prime, so I'm done there, but I've still got a branch over here, and 4 is not prime. What could go there? 2 times 2. Okay, I'm going to circle that, circle that. Oh, I'm done. So if I kind of put the little the circles, because that's my answer, I'm going to put that in order from least to greatest. So 2 times 2 times 2 times 2 times 3. That sure looks familiar, doesn't it? It's the same thing, right? This 2 right there, the 2, 2, 2, 2 that I'm multiplying, not adding, that's 2 to the 4th power, and then times 3. Notice that I got the same answer. No matter how you go about doing it, you're going to get the same answer. Okay, and you could have done it other ways too. Let's just do another one just to keep practicing. 120. What could go into 120? What about 10 times 12? That would work. Can anything go into 10? Yeah, because that's not prime. That's a composite number. 5 times 2? 5 is prime and 2 is prime, so I'm done on that whole branch, but I've still got 12 going. So what can go into 12? Maybe you're saying 3 times 4? Okay, so 3 is prime. What about 4? Nope, that can keep going, so that's going to be what? 2 times 2. Those are prime, so I'm done there. And now I'm done. I don't have any branches that aren't like circled. They've all ended. So I'm going to go ahead and put that together, and I'm going to go in order from least to greatest there. So I've got 3 of those 2's that I'm multiplying, so 2 times 2 times 2. Oh, I could just kind of condense that to 2 cubed. Then I have times 3 times 5. Well, I can't condense any more of that, so I will just go ahead and write that here. So 120 is equal to 2 cubed times 3 times 5. And we're just going to do one more. Let's do 96. Now, what could go into 96? Well, maybe 12. I think 12 can go in there. 12 times what? Hopefully you're saying 8. 12 times 8 would be 96. So what could go into 12? We could do 3 times 4. We could do 2 times 6. There's a lot of different ways, right? So if we did 3 times 4, I can go ahead and circle 3 because that's prime. And what can go into 4? 2 times 2. And I know that 2 is prime. Now what about 8? Okay, I'm going to go ahead and say maybe 2 times 4. And 2 is prime, and I know I can split 4 into 2 times 2. So I'm about to write this, and I'm going to end up writing 2 times 2 times 2 times 2 times 2 times 3. I got lost in how many I was saying right there. So I'm going to use exponents to help me so I don't have to do all that. So I know that I'm multiplying this. That's 1, 2, 3, 4, 5 2's that I'm multiplying by each other. So instead of saying 2 times 2 times 2 times 2 times 2, I can say 2 to the 5th power. And then I'm still going to say times 3 because I still have this 3 right there. And that is equal to 96. Again, that's not 10 times 3. 2 to the 5th power doesn't mean 2 plus 2 plus 2 plus 2 plus 2. It's multiplying it. So that is why we talked about exponents in the same video as prime factorization. I hope you understand.